Hey y'all, Miss Brown here, your 8th grade pre-AP science teacher. If you're an avid baby, you're watching the wrong video. Okay, y'all, so we got a little forest scene happening here. Pretty nice, pretty nice. Okay. Ooh, it's like really misty, huh? Well, like dawn action happening or some, you know? It's really cool. Lots of mist. Okay, y'all. Happy Tuesday, September 1st. Yes. So, y'all, I saw something on the socials this morning that said the Burr months are my favorite: September, October, November. And it made me think of back home, Massachusetts, and how much snow there is. I love me some cold months. So, y'all, let's get going. Today is Tuesday, September 1st. Like I said, tomorrow, September 2nd, on Wednesday, y'all have a little mini quiz. And then on Friday, you have your big quiz that I'm kind of counting as I'm not kind of counting, it's counting as a test, but I'm calling it a quiz because we're going to have 3 quizzes, topic 1, topic 2, topic 3. And then we're going to have our tech check, which is technically our test at the end of the unit. But it's a big old unit, so I didn't want to wait till the end to test y'all because that would have been a struggle to study all that stuff at once. Y'all, every time my ears and my face itch. So bizarro. I talked to Miss Gordon about it too, and she says the same thing happened to her. So I promise I'm not weird. Or maybe both of us are just weird together. Who knows? Okay, y'all. So I'm going to go to my second period science. I teach 2nd, 3rd, and 6th. So if you are one of those science classes, y'all should be good to go and in the right spot. Okay, so sorry. Okay, so hit 3rd week, and then I am going to walk through the PowerPoints. This is going to be kind of a long class recording, probably about 20-25 minutes. Can't be more than a half hour because I have 7th period class coming up next. So I'm going to walk through what we're doing, and then this way you can have this video to kind of help you out during your little mini quiz, and then during your bigger quiz on Friday. So I already did Monday yesterday, so we're going to do Tuesday, September 1st. So I'm going to click on this 1.2 plate tectonic slideshow and notes. So here's my friend, Chris Kessler. I borrow his slideshow so that way I can have y'all follow along with me, and I can talk to you guys about it. So you have this slideshow yourself. Let me show you how to get it. So if y'all look right here, in order to get this slideshow, all you do is click on this little button with the square and the arrow. And then it will, forget y'all, I have to double click when I'm in screencast. Then it's going to pop it open in a brand new screen for you. So what I would do, y'all, just saying, and I would do the same thing with the Continental Drift slideshow, is I would go here and I would star it. And then y'all notice you can have little tabs. So if you want to, you can choose another folder and you can create like a 8th grade science tab or a slideshow tab. That way you can have it saved. I'm not going to save this because I already have another version saved. Then you can also download it to save it for good. You can pop it open into a new window, or you can add it straight to your Google Drive, which is pretty awesome. So I am going to, I think what I have here is fine. I think that's big enough for y'all. Okay, so yeah, so here's the plate tectonic slideshow I'm going to walk through. And what I want y'all to do is, I'm actually scooted this part out. So I'm going to revise this right now. I did it for my 3rd and 6th period class because after I did it with my 2nd, I'm definitely the type of teacher that if something doesn't work or I need to change something, I change it right then and there. I don't like roll with something if I'm realizing it's not doing us any good. So what I did was I had my other classes, we are going to wait on page 16 and 17 until we do the lab. So we're going to wait on those 2. So I'm just trying to delete that page for y'all. Okay, awesome. And then what y'all are going to do is you are going to submit page 15 as your first part of your slideshow. Don't forget, tomorrow on Wednesday, there will be a little mini quiz. And it's going to specifically be about what I'm talking about today. Convergent boundaries, divergent boundaries transform, and what types of land features each of those create. So I'm going to walk through this slideshow. You will have your mini quiz tomorrow. And the first part of your assignment is going to be to add that page 15 to your journal. Okay, rock on. So this is the slideshow I'm going to go through, and I'm going to look at it right here. So plate boundaries, like I said, thank you, Mr. Chris Kessler, for allowing me to purchase your slideshow to use it for my class. And I'm going to zoom in a little so that way we can see it a little better. Awesome. So our essential questions for today is, what is plate tectonics? And what I want y'all to do is get out your trusty, dusty journal, and we are going to go to page 15. So on page 15, we wrote our original EQ, our rephrased. We're going to write what convection currents are, and yesterday we talked about our 3 facts. We are going to skip pages 16 and 17 for now, but we're going to revisit it after. I hope y'all just didn't see me rubbing my face behind. Okay, so we're going to skip these 2 pages. Don't cross it out. Don't rip it out. We're going to go back to it later this week. So today we're going to focus on pages 18, convergent boundaries, 19, y'all, it's always opposite. 19, divergent boundaries, 20, transform boundaries, and 21, subduction zones. So you are going to turn in page 15, which is your cover page. Then 18, 19, 20, and 21 today. You're going to skip 16 and 17 for now. So I would love for y'all to turn to page 18. And what I want you to do is on the side margin, write plate tectonics definition. Write plate tectonics definition. And we're going to write the definition for what plate tectonics is in a couple minutes. We are also going to talk about the 3 types of boundaries: convergent, collide, make mountains, 2 continental plates, a continental plate, and an oceanic plate. The oceanic plate is more dense, so it subducts. So that creates a subduction zone. Then you have divergent is when it divides or separates. It creates things like rifts. And then you have transform, which creates a fault line, and it gets stuck, pressure builds up, and then it creates earthquakes. So we're going to talk about those types of boundaries and what each type forms. So here's my little trick. Continental and oceanic crust. So I think of continental crust as kind of like grandma or grandpa or somebody that is older. And then I think of oceanic plate, I think Ocean Eyes, my girl Billie Eilish, and I think of like young, kind of teenage types, not like y'all, that are maybe a little bit older and maybe a little more self-involved. So here's my little trick. I think oceanic crust, I think Ocean Eyes, I think Billie Eilish, and I think dense. Like, and y'all, these are just generalities, okay? So it's what helps me remember. Other people I've seen have done the analogy with a older person and a model. I don't like that because I don't like to group all models as being one type of way. So my girl Billie Eilish is just one person, so I'm kind of using her as an example. So oceanic crust is more dense. It's more tightly packed. So that means that the oceanic crust, whenever I show oceanic crust, I always kind of do this. Oceanic crust subducts under the continental crust because continental crust is very brittle and it breaks easy, and it's very less dense. It is less dense than the oceanic crust. So oceanic crust is more kind of tightly packed. It's stronger, more dense, and it subducts under the continental crust, and it creates kind of volcanic activity, creates trenches and things like that. 2 continental plates, since they're both the same density, they just crunch up on each other, y'all, and they make mountains. I think of this as like running and you slide and then you hit a carpet or a rug and it buckles and it folds. So these things, y'all, are called buckled mountains or folded mountains. So for example, the Himalayan mountains are 2 continental plates that collided. Versus if you have a continental plate and an oceanic plate, the oceanic plate subducts and it creates those subduction zones, which is when you would kind of make your notes here. So as you're working through this slideshow, you're going to be filling out pages 18, 19, 20, and 21. To be clear, you're going to do the same 4 things on each page. You are going to define, you are going to draw, you are going to use it in a sentence, and then you are going to tell, this is the most important part, what landforms develop. So you're going to talk about what land features are made at each, which is what your quiz is going to be about tomorrow. So 2 types of plates, and then 3 what crustal features they each make. So literally, y'all, pages 18, 19, 20, and 21 go over all these essential questions, which is pretty cool. We are going to skip this one, and we are going to hop to this slide, which is, oh, y'all, I don't like when it doesn't tell me. I think it's because I have it too big. Yeah, that's why. So now we're going to be on slide 5. So there are 7 continents today. The big supercontinent before was called Pangaea, Pangaea, and that was hypothesized by Alfred Wegener. And we already talked about continental drift in the last video, so I'm not going to talk about it again this time. Hop back to my last one if you want to learn more about that. And if I remember, I'll link it in the top corner. So here are the continents that we know today. They used to be together called Pangaea, and then they slowly split into other things like Eurasia, Laurentia, Gondwana land, but we don't need to touch too much on that. So here is Alfred Wegener, our guy Alfred Wegener. So continental drift theory, I'm not going to talk too much about him because I talked about him in the last video in one of these corners. And then here's our new man, Harry Hess. So Harry Hess is responsible, y'all, for seafloor spreading. He's the one that I talked about in the last video that was in World War II, a Navy vet. And he sent all these submarines down to see if there were any enemies coming after him. And they freaked out when they were getting all these pings back and realized it was the ocean floor looks just like the floor on top. There was mountains, there was valleys, there was trenches, there were volcanoes, y'all. So that's when seafloor spreading happened. So what seafloor spreading is when you have 2 oceanic plates that separate, that diverge. And what happens is, see if I can do this. They go like this and they separate. And then what happens is right here where my kind of forearms are is magma comes out. Magma comes out. And then it hardens. Y'all. Oh, this is going to be on the internet for everybody to see. Then it hardens and then it forms new seafloor in the middle. So what happens is the newer seafloor is formed at the middle at this kind of ridge. It's called a mid-Atlantic or a mid-ocean ridge. So the newer seafloor forms right when the plates divide. And then the older seafloor, my fingertips, keep going out, 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 out. So along the ridges is the new seafloor and towards the outer edges is the old seafloor. Then we know that the earth is not an infinite space. It's not forever and ever. So what happens is it goes like this, and then it's like a conveyor belt. Eventually this goes, and then it's going to hit another piece of oceanic crust over here, and whichever one is more dense is going to subduct. So then eventually that old kind of oceanic crust is going to subduct under the newer crust. And y'all, it literally creates this kind of conveyor belt, which this kind of should remind you of something which I'm going to talk about next. So as Harry Hess was doing that business with his submarines, he realized, whoa, the seafloor looks pretty cool. We're going to map this out and see what it looks like. So he ended up mapping out the seafloor and then realizing that there were these tectonic plates, about a dozen of them. So the theory of plate tectonics is what these 2 kind of things together made. Continental drift, the theory of seafloor spreading together finally formed the theory of plate tectonics, because then we had the claim, continents are moving, evidence, fossils matching up, landforms like mountains and rocks matching up, the continents fit together like a puzzle piece, and y'all, that last one that a lot of you missed on the quiz was glaciers. Remember, the continents were up top, glaciers formed like a chair moving across the ground, scratches. So we had all these striations, these glacier striations, and then eventually those continents drifted to the equator, and it's hot at the equator. So the people are going, why are there these glacial striations? Because the continents drifted. So fossil is one piece of evidence for continental drift. The plates, the continents fit together like a puzzle. The landforms matched up, mountain valleys, mountain ranges, and then glaciers. So a lot of people in that quiz, y'all said that there wasn't evidence for continental drift. There was. The claim was continental drift. The evidence was those 4 things. They didn't have the reasoning. So Harry Hess came along and gave the reasoning about the plates moving, which then together made plate tectonics. Okay, so plate tectonics, I want y'all to copy down this definition on your page 18. Right along the side, I want you to copy this definition down. Y'all should get in the habit of text coding, so let's circle some vocab. So plate tectonics is vocab, so circle that. And it's the theory that Earth's outer crust, the lithosphere, so crust, lithosphere underneath, is divided into plates. And then those plates glide over the plastic like a asthenosphere, like that silly putty material. So you have the hard, brittle crust. The lithosphere underneath is a little bit more, has a little more give, a little less rigid. Then you have the mantle, 80% of the Earth's layers. top part of that mantle is the asthenosphere, like silly putty. And that's what the plates glide on. Underneath the asthenosphere is the mantle, and that's more like syrup or molasses, so it's even more liquidy. Then the outer core is liquid, and the inner core is like a solid sphere, like a solid marble ball. Because it's so dense, it makes it solid, but it's so hot, 1,000 degrees hotter than the sun, y'all. So hot that it melts the outside outer core. So inner core solid, made of metal. Outer core liquid, also made of metal. Mantle 80% molassesy. On top of the mantle, asthenosphere, a little more solid like silly putty. Then the lithosphere, and then the crust. The crust is the plates, sits on the lithosphere, and moves on the asthenosphere. Whew, there go my eyes again. So this picture has 16 plates. We're going to focus on 12 of them. We're not really going to focus too much on the Juan de Fuca plate, the Cocos plate, but we are going to talk about the Nazca plate, South American, North American, Caribbean, African, Arabian, Eurasian, Philippine, Pacific, Indo-Australian, Indian, and the Antarctica plate. Scotia plate, I don't think, is one of the ones we talk about. So there's 16 here, but we're going to focus on 12. So plate boundaries, the engine for moving the plates, the engine for plate tectonics is convection currents, y'all. So you're going to hop back. Sorry, I keep looking down. I'm just trying to keep an eye on the time. You're going to hop back to page 15, your cover page, and I want you in the center.
Attention teachers and staff, we have an AED drill in the SAC. This is just...
Hey, y'all, sorry, quick announcement. So I want y'all to write convection currents in the center. If you don't have room, you can do it on your page 18, that's fine. So copy this definition down. The engine that drives convection current, the engine that drives plate tectonics is convection current. Think about engine, y'all. Doesn't matter how hot your ride is. If you don't have an engine, your car ain't going anywhere. So the engine is like a metaphor for the cause or the source of plate tectonics. So convection current, that hot air rising because it's less dense, cool air sinking because it's more dense, creates this conveyor belt. Y'all don't worry, it's just a drill. Creates this conveyor belt. And if y'all think about it, if you're standing on a treadmill, you're kind of forced to move. So that's what the plates are. The plates are on top of this convection current treadmill, and it's causing it to move. So if y'all could please write this down in between topic 1 and topic 2 on your page 15. And that's why you're going to turn this page in, because you have all this jazz to show me. Okay. I don't think that's too loud. I think I can keep going because I don't want to run out of time. I hope this isn't distracting. Okay, so here are plate boundaries. Continental crust are layers of rock which form the continents. It also forms shallow seabeds to the shore, floats on top of the asthenosphere. Older than oceanic crust, mostly granite and rock. So y'all, this is the other part to the grandma and the Billie Eilish. Grandma, continental crust is old. It's tired. It's brittle, y'all. I mean, my grandma's young and fresh. I don't know about y'all's grandmas. My grandma could like take anybody. But we're talking about like the quintessential, like think in your head, like a movie grandma. Old, crippled, has the cane, and very brittle. So that's continental crust. It's a lot older because remember, the seafloor spreads and it's constantly creating new crust. So the continental crust, y'all, has been here for like 300 million years. So it's old and it's brittle. And then the oceanic crust is younger. Think Billie Eilish, young, but a little more dense, like self-involved, self-absorbed, more dense. So younger material is more dense. So hence, the newer seafloor that comes out of the middle is the most dense, and then eventually it's going to rotate, it's going to keep going, and then it's going to hit other seafloor, and then that kind of more dense seafloor is going to go underneath. So continental crust is thicker and less dense than oceanic crust. So the continental crust is thicker and less dense than that oceanic crust. So plate boundaries, you have your oceanic crust. So y'all can be kind of thinking about this page 16 as we kind of start thinking, but you don't need to be filling anything out here. So you should be kind of thinking about these boundaries, like what types of boundaries do these relate to? So oceanic crust, y'all, think of Billie Eilish, a thin young layer that underlies the ocean basins. Consists mainly of basalt, a type of rock. It is younger than the continental crust. So grandma, continental, Billie Eilish, ocean. It is more dense. Okay, so you don't need to do this. If you want some more practice, you can to make a T-chart. You can do it in your head. We're not going to get to this part just yet. We'll probably do this for review for the tech check, so just keep this in mind. And then, y'all, here are the boundary types. So what happens at these boundaries? You have three things. You have, and y'all, I don't know why these are covering up those things. I apologize. So converge is when they collide, come together. Diverge is when they separate, create a middle separation. And transform is when they slide past each other. So I have some visuals with arrows for y'all. So ready for a song and the melodies to the Addams Family. So that's my thing. I got to get going soon. So converging is colliding. Diverging is dividing. Transforming it is sliding. We are the plate boundaries. Da-na-na-na. 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 Y'all, I didn't make this one up, but it's cute though. So converging is colliding. Diverging is dividing. Transforming is sliding. We are the plate boundaries. So I hope that gets stuck in your head for the test. Okay, plate boundaries. So divergent plate boundaries is when they divide. You can have two oceanic crusts dividing, and then that mid-ocean ridge forms, magma comes up, makes new seafloor. This process is called seafloor spreading. Our man, Harry Hess, and new crust is created. I wish I didn't itch every time I recorded. Divergent boundaries, dividing or moving apart. So you can have two continental crusts diverge, and it creates a rift valley. So when two oceanic plates separate, it creates a ridge, and when two continentals separate, it creates a rift. New crust is also created. An example is the Great Rift Valley in Africa. Over millions of years, water will eventually fill that valley. So you end up with a valley kind of basin. So a mature ocean or a new ocean basin, caused from two continental plates separating, dividing. Okay, plate boundaries transform when they slide and slip. So there's a couple transform faults. One of them is literally called the slip slide because they slip and then they kind of slide. So creates earthquakes, y'all. Think of the San Andreas Fault. So it says now entering North American plate. A dream. And if y'all take a look, transform boundaries is when these are sliding. And y'all, this is super slow. This is not something that happens. Had to itch my nose again. This is not something that happens very quickly. Yes, the earthquake itself devastates and causes all this kind of chaos immediately, but it took millions of years, thousands of years for it to build up, for it to finally slip, and then create that earthquake. Y'all, that earthquake shook me. Okay, I'm happy that alarm is off. So the crust is neither created or destroyed. So this one, divergent, you have new crust being created. Convergent, you kind of have crust being destroyed. And then transform, it's kind of neither. Yeah, you have some pieces kind of breaking up, but you don't have any magma coming up, making new. And then you don't have any breaking to make mountains. Oh, my eyes. Many of these boundaries are formed on the seafloor. And the most famous transform boundary is the San Andreas Fault in California. So y'all, I was born in California. So that's why we had so many earthquakes, because of this big San Andreas Fault. Y'all need to be reviewing this for realsies for the quiz tomorrow. So what happens when the plates converge or collide? Continental, folded mountains like the Himalayan range. You run, you hit a carpet, you slide, the carpet buckles up and makes folded mountains. You have a continental plate and an oceanic plate. The oceanic plate subducts because it's more dense. So volcanoes form, because what happens is it kind of creates this opening. This plate that goes down literally agitates, like it annoys the other stuff down there, and it causes it to rise up. Think of the Cascades in Oregon or Oregon and Washington. And then you can have, where am I, y'all? Convergent, oceanic. So you can have two oceanic plates converging. And you're going to get a volcanic arc. So the Aleutian Islands in Alaska. So you're going to have these plates colliding, and then it's going to kind of create these volcanic arcs. So a lot of the times what happens is you have this kind of magma coming up from the surface and creating these little dot islands, much like the Hawaiian Islands. Okay, plate boundaries, converging, continental, two crusts collide. You have mountains, folded mountains. This is not a subduction zone because the two, and then they go up because they're the same kind of density. Versus if you have convergent, continental, and oceanic, then you're going to have subduction zone. The Billie Eilish plate, the more dense, younger plate is going to go down. And then the grandma plate, the older, less brittle, is going to stay up and kind of ride across the top. So y'all, this is where volcanoes form. So volcanoes can form from convergent boundaries. So this is where it gets a little tricky because you can have multiple, volcanoes can form from multiple boundaries. So volcanoes form on the continent, and then a trench forms at the place where the plates collide and you have a subduction zone. So if y'all look here, you can see this oceanic plate on the left. It's got the blue water and it is more dense, so it is going to subduct underneath the continental plate. And then y'all will see right here, you're going to have that volcano that's going to kind of pop up on that continent. And this is a subduction zone. So Cascade volcanoes, Washington, Oregon, California. And then over here, you can see kind of a picture of those Cascade mountain ranges. So converging boundaries, oceanic. So you have these two coming together. What's going to happen is you have a collide and a push against each other. So if you have two oceanic plates coming towards each other, it's like the survival of the fittest regarding ocean plates. So the older crust goes below the other one. So the older one is going to go underneath the other one and it's going to subduct. So that kind of older of the two oceanic plates is going to subduct. But still keep in mind, oceanic plates are typically younger than continental plates. So the older of the two is going to subduct. So you have the Aleutian Islands, you have that old crust being destroyed as it goes down, it gets destroyed and it literally all gets recycled, and then the convection currents bring it back up and give it new life, which is pretty cool. The circle of life makes me think of. So y'all, I put this in here so that you have a visual of exactly what is what. So y'all, if you look, it says divergent plate, transform plate, convergent plate. And then it has a sketch. It talks about the direction. It talks about the features of each and then some examples, y'all. So you have this to use for your test, for your quiz, for your notes, which is pretty cool. So let's review the three types of plates. On 3 slips of paper, write C, D, and T for convergent, divergent, and transform. Get with a partner, get with somebody at your house. So you're going to act these out. So I want y'all to practice. Demonstrate to your family. Hop on FaceTime. I know y'all are FaceTiming nonstop. And act these out. Show me convergent. Show me divergent. Show me transform. I want to see it. That's my hint. I got like 5 minutes and then I got to go, which is perfect because we're almost done. So Ring of Fire is a long chain of volcanoes that surround the Pacific Ocean. You know, y'all know it's coming. I fell into a burning ring of fire, went down, 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 and flames went higher. Burns, 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 ring of fire, ring of fire. Y'all, I love Johnny Cash. Let's pause for a minute. Talk about how amazing Johnny Cash is. So Ring of Fire, y'all, this is what he's talking about. So it's a long chain of volcanoes that surround the Pacific Ocean. And if y'all look at this picture, these are where all these plate boundaries are. So these are where those different plate boundaries are meeting, which is causing all this kind of volcanic and all this activity. So one of the most geological active places on Earth, the site of frequent earthquakes and volcanic eruptions, because you have a lot of transform, you have a lot of diverge, you have a lot of convergent boundaries happening. So this is where like all the plates are kind of meeting. And it's caused by the plate boundaries converging, diverging, and transforming. So we're going to skip this. And this is all stuff, y'all, if you need to practice, be my guest, you can totally do it, but we're just going to skip it. So this is a great little kind of practice. Look at each of these cards and in your head, plates collide together. Which one is it? Great Rift Valley, which one is it? So you don't physically need to touch and do these, but you can look at these 1, 2, 3, 4, 5, these 10 cards and say, should it be a convergent, should it be a divergent, or should it be a transform? So you don't need to physically do this to practice. And that's what it will kind of look like if we did it for real life. So y'all, check for understanding. Can you explain plate tectonics? You should have written plate tectonics on your trusty dusty journal on the side. Can you name the 3 types of plates? So after you're done with your convergent, divergent, transform, and then subduction, it's not a type of plate, but it is involved. You should be able to answer that. And then y'all, the types, this is the important part. This is what your quiz is going to be about. What do each plate cause? And it's not super simple because volcanoes can be caused by a continental and an oceanic plate converging, or it can be caused from 2 oceanic plates diverging. When oceanic plates diverge, you get the mid-Atlantic ridge, but when continental plates diverge, you end up with rifts. And when you have transform plates sliding, you end up with earthquakes. But y'all, sometimes when plates converge and make mountains, you end up with earthquakes. So you kind of need to make sure that you get all of that stuff sorted out. And don't forget to hop back to this page, slide 22, and this will be a useful piece to help you even fill out pages 18, 19, 20, and 21. So don't forget, y'all, you are going to hit next, and then you are going to turn in page 15, 18, 19, 20, and 21 to this assignment. So if I look, it says assignment. You should have a blue submit button. And notice how it says a website URL. So you are going to upload your slideshow that you've been adding your slides to, and you're going to pass the same slideshow in that you did journal pages 1 to 14 in. Y'all, that was a lot, but you have me in your little pocket so you can pause me and watch me and fill out your stuff. And as you're taking your quiz tomorrow and your quiz on Friday, remember, open journal, open Canvas, open Miss Brown videos. Okay, bye, y'all. I love each and every one of you, and you fill my buckets each and every day. Overflowing. Bye, y'all. Love you.